Hello everybody. So today I'm going to be going over the review. So if you need help, this is a review to help you go feel more confident about your Bundle 3 test, okay, which is on Wednesday. So let's get started. And number 1 says, when the fuse ignites the contents of a firework, oxygen is consumed and carbon dioxide is released as a result of which type of chemical reaction? Okay, so if we know a firework explodes. Okay, so if a firework explodes, and if you know anything about fire has to have oxygen in order to actually ignite and function. So anytime you see a firework or anything that has that, and you see oxygen is needed, we know this is a combustion reaction because oxygen was needed and carbon dioxide was the product of it. Okay. Okay, so the second one, we're balancing this equation. So we're going to use our rap sheet. So over here, remember we have our reactants and products. So we have calcium right here. We have oxygen, hydrogen, and carbon. All right, so if we have calcium here, we have to have it over here. So we have 1 and 1. So 1 calcium here, 1 calcium here. Oxygen. So let's look. We have an oxygen right here, and there's a 2. So we know that there's 2 oxygens. But, oh wait, there's 2 oxygens, but there's also 2 here. So we know that this is 4. Okay. Okay. And then on the other side, we see that there's an oxygen here and an oxygen here. So we also know that this is 3 and this is 1. Okay, that's going to be 4. Okay, so hydrogens, same concept. Hydrogens, we have 1 right here. So you see that there's a 2. Same thing for over here. There's a 2. Make sure you're looking at the subscript. And then for calcium, here's 1 and here's 1. So guys, if you notice, these are all balanced. So we know that this is balanced. So each coefficient will be a 1. Okay? And then it asks you to do a ratio. Okay? So a ratio, remember, you look at the coefficients only. Okay? So we have the first coefficient is 1. The second coefficient is also 1. But remember, in order to separate them, we have to put a colon. So the plus sign is a colon, and then we have 1. And if you have an arrow, you're going to have 2 colons, and then go back to the next one. If you see a plus sign, remember that's a colon, and then 1. So your ratio is this right here. This is your ratio. Okay? Okay, so it's a 1 to 1 to 1 ratio. Okay, so number 3, we're talking about peroxide. Okay, so peroxide is a byproduct of cellular metabolism in aerobic organisms. The reaction shown occurs within the cells to prevent accumulation of hydrogen peroxide. So it says, what kind of reaction is this? So remember, right here we have a whole compound, a whole molecule, and then it gets broken down into 2 types. So remember, if you hear me say or see the word breakdown, that's your key word. So if it's going to be broken down, it's a decomposition. Okay, and it's asking if it is balanced. So let's do the wrap. Okay, so you have hydrogen and oxygen. So here's your subscript. So we know we have 2 hydrogens. Here we have 2 hydrogens. Okay, oxygens, we have 2 oxygens here. And, oh, there's a difference. We have 1 here and 2 here, so we have a total of 3. So the reaction is not balanced. Okay, and then we have to figure out a way to make it balanced. So remember, oxygens, we're trying to get an even number of oxygens. So what I would recommend, we use a different color so you can see. Let's put 1 here, here, and here. So we have 2 oxygens here. If we put a 2 right here, that would give us a total of 4. Okay? So remember, whatever you have on this side, you have to have on the other side. Okay? So if I have 4 oxygens if I have 2 oxygens here, okay, 4 total. Also, we have to look at the hydrogen. So if I have a 2 here and a 2 here, I now have 4. And whatever you have here, you have to do the other side. Okay? So I would put a 2 here. That way I would have 2 hydrogens and 2 oxygens. Okay? Make sure y'all can see that. This is a 2. Okay, so number 4, there's 15 grams of NaCl. So NaCl, okay, they produce 122 grams of AgCl plus 93 grams. By the way, this should say NaNO3, and this should say AgNO3. Okay, so we're looking for X. Okay, so remember, step 1 is add like terms. So remember, we're always adding first. So we're adding this side first. So 122 plus 93. I need my calculator, so give me 1 second. Okay, 122 plus 93 is 215. So we have 15 grams plus X equals 215. The second step is we're going to subtract to get X alone. Now, sometimes these may change, okay? But you have to be very cautious of what you're doing. So we're only adding and subtracting in this. We're not multiplying or anything. So we're trying to get X alone. So we're going to minus 15 from this side, minus 15 from this side. So 0. And I know that's a simple equation, but I don't know it. We have 200. So X equals 200. Okay, and that's 200. It's going to be, what is it? AgNO3. So this is 200 grams of AgNO3. So this is your answer. Okay, so number 5. What type of reaction is presented in FeCl2? So iron and then chlorine, and it goes into iron chloride. Okay. So we have, let's rewrite it real fast. So we have Fe plus Cl2 goes to FeCl3. So remember, if it's a type of reaction, we're looking at, we're going to be looking at synthesis, decomposition, or combustion. Okay, so synthesis, you're making a whole new product. So let's figure this out. So we have 2 elements and they combine. So hopefully you're listening. This is a whole new product. So hopefully you know that this is synthesis because you created a new product. Okay, and it's asking you if this is a balanced equation. So let's figure this out. So we have set up our wrap. We have reactants on one side, products on the other. We have iron and chlorine. We have 1 iron here, 1 iron here, 2 chlorine here, 3 chlorine here. Okay, so remember, your job is to get an even number on each side, okay? Or one that they both can equal out to, okay? So one thing that you can do is, if in this situation, you can move this subscript in front of this as a 3. So remember, if you do 2 times 3, that equals 6. And whatever you have on the other side, you can do the other. So we're trying to get 6, so we put a 2 here. Okay, so we're in a sense flipping the subscripts. So the subscripts go in the opposite coefficients. Okay, so now I have 3 times 2 equals 6. Okay, so they're both happy. They both have 6. But now let's look at the irons. There's 2 here. So 1 times 2 equals 2. So this side has to equal 2 as well. So they're both happy now. Okay, and then it asks you to do the ratio. Okay, so remember, the ratio, we're looking at these big coefficient numbers. So we have 2. If you see a plus sign, there's a colon. Then you have 3. Okay, the arrow is going to be represented by 2 colons. And then you have a 2. Okay, so that's the coefficient. Okay, so you mix calcium oxide with aluminum and yield aluminum oxide and calcium. Balance the equation for this reaction and state the ratio. Okay, once again, guys, we're just making the wrap. So we have calcium, 1 calcium. So 1 and 1. We have oxygen. 1 oxygen here. Hopefully you realize that there's a 3 right behind it. There's a 3 here. And then aluminum. So we have 1 aluminum here and 2 aluminum right there. Nope, I lied. That's 2. Okay, so now we are going to try and balance it. Okay, so let's look at oxygen because it looks weird. So we have a 3 here. Let's see what we can put on the other side to see if it's balanced. So if we put a 3 here, we are now going to have 3 calcium and 3 oxygen. Okay. And if we have 3 calcium here, we're going to have 3 calcium right here. Okay. And let's look at aluminum. Aluminum has a 2 here. And the aluminum right here there's only 1 aluminum. So we're going to have to change that to a 2. Okay, so this is a 2 now. So they're all happy. Okay. Okay, so your coefficients are 3, 2, and 3. Okay, so you remember your and then we have to do the ratio. So we always look at the coefficients. So we have 3. A plus is the colon. Then we have a 2. The arrow, you have 2 colons. If there's nothing in these blanks, that means there's a 1. So we have a 1. Another plus, so we have another colon, and a 3. Okay, so that's how you do number 6. So number 7, what type of reaction absorbs energy and requires energy for the reaction? Your keyword here is absorb. So this means to go into. So that's your key. So if it goes into in a reaction, that means the heat is lost. So if heat is lost, this is going to be endothermic. So by the way, I'm going to write endothermic in blue. So this is endothermic. Going to rewrite this too. Okay, so this is endothermic. So the heat is lost. You're not going to feel it, so it's going to be cold. Okay, so now we're going to look at the next one. So it says emits. Okay, so this means releases or exits. Okay, so I'm going to keep writing a red. So if it releases or exits, that means you're actually going to feel the heat. So it's released from the reaction. So this is exothermic. So heat is released. Okay? So that's the difference between the two. So in this one, heat is lost, heat is released, or heat goes into. So in endothermic, you're not going to feel the heat. It's going to be cold. And in exothermic, you're going to feel heat. Okay? All right, so number 8 talks about, let's see, we're talking about photosynthesis, and we're trying to balance the equation. Okay? So let's have our wrap again. Okay, so we have carbons, hydrogens, and oxygens. So if we look at carbon first, there's a big old 6 in front of this one, so we have a 6 here. Here we have a little 6 beside it, so we have a 6 here. Hydrogen, we have 2. Over here, hydrogen has 12. Okay, oxygen, we have, remember that 6 goes all the way through, so we have 12 here, plus 1. So we have 13 right here. And over here we have 6 plus 12, so we have 18. Okay, so if we're looking at this, the weird one is oxygen. Okay, oxygen and hydrogen. So let's figure this out. So if we have a 12 here, the easiest thing to do right here is to put a 6. Okay, so if I have 6 here, that means this is going to give me 12. Okay, so let's do this real fast. Sorry. So you have 2 times 6 equals 12. So now they're both happy. Now let's look at oxygens. So this side has, the product side has 18. So now let's see how many oxygens we have on the reactant side. So remember, now we have 12. And now we have 6. So now we have, oops, my bad. By the way, this should say, oops, maybe. My bad, guys. I'm so sorry. So mark this out, and we have 12. And now we have 18. So 12 plus 6 is 18. Okay? So it says, once again, let's do this silly ratio. So I'm going to erase some of this stuff so you can see it. Okay, so our first coefficient is a 6. There's a plus sign, so we put a colon. The second coefficient is a 6. Oh, this is, okay. We have an arrow, so that means we do 2 colons. Remember, if there's a blank here, that means there's a 1, so we do a 1. And here's the other coefficient, and it's a 6. Okay, so this is your coefficient ratio for photosynthesis. Okay, so number 9. Which equation properly describes the reaction of X and Y? Okay. So let's see. So we have X and we have Y. So it looks like we have 3 X plus 1, 2, 3, 4, 5, 6, 7, 8. 8 Y goes to, okay, 1, 2, 3. So 3 X Y 2 plus 2 Y. So you're like, Wes Wilkins, how did you get this? So the reason why I got this, so this side I'm guessing makes sense to you. Okay, this side over here is the one that doesn't make quite as much sense probably. So the reason why this is 3xy2, okay, so we have the x's are right here, okay, and there are 2 y's connected to them. Okay, so it would be 3 x's that are connected to 2 y's each, and then there are 2 y's left. So these the ones encircled in blue are my y's. So there's 2 y's left. Okay, so your answer would be D. Okay, in chemical reaction, the total mass of the reactions must equal the total mass of the products. Okay. Okay, number 11. Okay, number 11. The following symbols represent one atom of different elements. Okay. By the way, you'll see this type on your test, so make sure you pay attention. Which of the above correctly represents a chemical reaction showing the law of conservation of mass in a chemical reaction? Hey, remember, reactants. So either if it's reactants must equal products, and vice versa. That's what the law of conservation of mass says. So let's see. Which one is following that? So let's see. We have 1, 2, 3, 4, 5, 6 over here, and then we only have 2 here. So if you're listening, this side has 6 little white dots. Over here, there's only 2. So we know this one doesn't work. So I'm going to mark this out in red because these aren't even. Okay, so let's see. We have 1, 2, 3. 1, 2, 3. Okay, this could be it. So we have 1, 2, 3 whites. 1, 2, 3 whites. 1, 2, 3 little black ones. 1, 2, 3 little black ones. So this could be it. So now we have 1, 2, 3 black ones. 1, 2. Nope, not it. We have 1, 2, 3, 4, 5, 6 little black ones and 3 white ones. And how in the world did we end up with 1, 2, 3, 4? Okay, so your answer would be number 2. Okay. What are the correct coefficients needed to balance the following equation? Okay, let's do the wrap again. You're going to do this every time. So aluminum we have 1, aluminum we have 2. Oxygen we have 2, oxygen we have 3. Okay. So we got to get oxygen and oxygen to an even number that they can easily get to. Okay, they both have to be the same. So once again, just a simple hint. If you have this kind of situation, you can just flip-flop the subscripts with the coefficients, or you can just work it out. So if there's a 3 here and there's a 2 here, 6 is the number that they're both going to equal to, the least common multiple. So you have a 3 here. So 3 times 2 equals 6. Put a 2 here. 3 times 2 equals 6. So they're both happy. Okay, now we're looking at aluminum. So there's a 2 here and a 2 here. Remember, they're multiplying. So now I have 2 times 2 equals 4. Okay, so what would I have to put over here to equal this? So I would have 4 aluminum over here. Okay, so they're all happy. So it's asking what type of reaction this is. So look, we have, I'm going to use a different color for this one. Okay, so we have an aluminum and an oxygen. We have 2 separate elements, and they combine to make one whole one. So this is a whole new product. So if we're making new products, this is going to be synthesis. Okay. So the next question, number 13. So what chemists measured the the mass of mercury 2 oxide, okay, and then heated it and measured the mass of the resulting liquid. Her measurements are shown in the chart. So we're looking at mercury 2 oxide. We started with this. Okay. Why is the mass of the product less than the mass of the reactant? So she says she heated it, right? So we're trying to figure out, why is mercury oxide, why did it start here and end with this? Why did it get smaller? So her key word here is heated it. If you heat something up, gas can escape into the atmosphere. So of course it's going to be lighter. Okay, so that's going to actually be your answer. Why is the product less than the reactant? Okay, when the chemist heated it, the gas, when was it a liquid? Okay, so when she heated the oxide, the mercury oxide, some of it went into the atmosphere oops, sorry, I can't spell. Atmosphere as a gas. So it was still there, but it just escaped. Okay, it escaped into the atmosphere. Okay. In her classroom, when ammonium hydroxide mixed with copper 2, in your classroom, when ammonium hydroxide is mixed with copper 2, the products are a powdery substance called copper hydroxide and a liquid known as ammonium sulfate. Your teacher says it's a chemical change. What is the evidence in her claim? So if you have done this one, if your teacher showed you this, when they mix together, okay, so when they mix together, I'm just going to show you, I'm just going to pretend this is it. So when they mix together, here it is, there's actually going to be a little participant. There's going to be a little participants at the top. So when they mix together, they actually make a product. They make an actual visible product. Okay, what's the evidence? There is Ooh, sorry guys, don't know how to spell this. So, give me 1 second. Okay, so let me make sure I'm spelling this right. Okay, so what forms is a precipitate. Okay, so there is you can actually see something form from this. So a precipitate is a product of this reaction. Okay, so you may want to look this up on YouTube. Okay, so you may want to look this up on YouTube. Okay. So you may want to look this up on YouTube, especially this one. That way you can actually see it form. Okay, so guys, this is the Bundle 3 review video.